The last lesson that we looked at was the exponent laws, and hopefully we'll remember that if we are multiplying exponents with the same base, so let's say we have 2 to the power of 4 times 2 to the power of 6, then we can simply add the two exponents together, so 4 plus 6 gives me 2 to the power of 10. Similarly, if we had, say, 3 to the power of 5 divided by 3 to the power of 2, we can subtract, because we're now dividing these, and have 3 to the power of 3 as our simplified answer. And those ones are a little bit easier to figure out. So now let's take a look at some other things that we can do with exponents, and specifically what we call the power rules. First of all, if we have 2 to the power of 4 and we have it in brackets here and it's raised to another exponent, let's think about what that means. That means that we have 2 to the power of 4 times 2 to the power of 4 times 2 to the power of 4. Now if we wrote that out each as their repeated multiplication, that's 2 times 2 times 2 times 2 for the first 2 to the power of 4, and then it's multiplied by another 2 times 2 times 2 times 2, so that's the second 2 to the power of 4, times the third 2 times 2 times 2 times 2. Now if we were to simplify this and write it in exponential notation, meaning we want to count up how many of the same base we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So 2 to the power of 12. If we take a moment and look back to what we had in terms of our exponents here, 4 and 3, how can we get 12 from 4 and 3? Well, 4 times 3 gives us 12. So this is actually the same as 2, and if we take 4 and multiply it by 3, we'll get the 2 to the power of 12. And this is actually what we call the power rule. So if we have any integer a, as long as it's not 0, and we raise it to the power of m, and then that whole thing, which is a power, is raised to another exponent of n, those are both whole numbers, then we can simply say that a is raised to the power of m times n. So let's take a look at a few examples here. If we have 3 to the power of 4, and that's all raised to the power of 2, my base is 3, and then we have 4 times 2, so 4 times 2 is the exponent, which simplifies to 3 to the power of 8. Looking at the one beside here, 5 to the power of 0 and 5 all raised to the power of 3 is going to be 5. 0 times 3 is equal to 5 to the power of 0. Looking at our last example, or last two examples here, we have a negative, and then we have in brackets 7 to the power of 2, and that's all raised to the power of 2. Notice that the base here is really the 7 to the power of 2. The negative is not part of it. So we'll just leave the negative as it is, and then we do 7, and we look at our exponents. We go 2 times 2, which is 4. So this will give us negative 7 to the power of 4. Finally, D here, we have a negative 3 as our base. So the negative is included because it's inside the brackets, and it's raised to the power of 3, but that's raised to the power of 2, and so we multiply the 3 times 2 together, giving us negative 3 all to the power of 6. But we can simplify that a little bit further because we remember the rule that if we've got an even exponent with a negative base, it's a positive value, and it's simply 3 to the power of 6. Now let's look at some other things that we can do with powers. So if we consider 4 times 2, all raised to the power of 4, again, let's think about doing this in repeated multiplication. So 4 times 2, and that's 4 times 2, and that's another 4 times 2, so 3 of them, and we need this 5 times. Now, if we remember that it's actually multiplication happening between each of these, so there's a little multiplication sign understood in between each of these brackets. Okay? And remembering that 2 times 4 is the same as 4 times 2, so we can group all of the 4's together. So we have 1, 2, 3, 4, 5. So 4 times 4 times 4 times 4 times another 4. And then we can group the 2's together, and we'll have 2 times 2 times 2 times 2 and times 2. That simplifies to, so there's 5 of these 4's and 5 of these 2's, so 4 to the power of 5 times 2 to the power of 5. And hopefully you can see that all we've done is distribute this 5 to both the 4 and the 2. As a rule, we say that a times b, so those are any integers except 0, to the power of m, can be written as a to the m times b to the m. And this will sometimes make our calculations easier to do, and especially when we start to use variables like x and y as the a or b. Again, let's look at a couple examples here. So if we have 3 times 2, all raised to the power of 4, we're asked to write them simply as a product of powers, so we don't need to actually solve these questions. The 4 here, we're going to distribute it to the 3 and to the 2. And we can only do this if we've got a multiplication, or we'll later see if we've got a division happening there. So this will be 3 to the power of 4 times 2 to the power of 4. We couldn't do this if this was an addition or a subtraction in here. The next one, same idea, negative 4 to the power of 2 times 3 to the power of 2. And again, we can simplify that a little bit further because we know that a negative base raised to an even exponent will be positive. So it's 4 to the power of 2 times 3 to the power of 2. The final thing that we would like to look at is what happens when we have a quotient raised to a power. And quotient simply means when we have division, and that's all raised to a power. So if we have 3 divided by 4 raised to the power of 3 in repeated multiplication, that would be 3 over 4 times 3 over 4 times 3 over 4. And if we remember back to how we multiply fractions, we multiply across the numerators, so 3 times 3 times 3 divided by, multiply across the denominators, 4 times 4 times 4. Well, that can be simplified in that we know the 3 times 3 times 3 is simply 3 to the power of 3, and then the bottom, the denominator, is 4 to the power of 3. So the 3 here, just like with multiplication, has been distributed to both the 3 and the 4. So if we have, and I'm going to write it over here, a over b, and that's raised to the power of n. So a and b are any integers, can't be 0, and n is any whole number. Then we can simplify that and write it as simply a to the n over b to the n. So looking at a couple examples, we've got division here, so we know that we still need to distribute the 3 to both the 5 and the 3, and so this could be written as 10 to the power of 3 divided by 5 to the power of 3. And that might be a little bit easier to solve. Same thing with b, but now we have it written as a fraction, so 1 to the power of 6 over 10 to the power of 6. And that we can simplify a little bit more because we know that 1 to the power of 6 is simply 1, and so 1 over 10 to the power of 6. But we don't need to solve what 10 to the power of 6 actually is. Hopefully we remember that anytime we've got 10 as a power, then it's going to be 10 times 10 times 10, 6 times, and that would just be 1 with 6 zeros. Finally, let's look at a few examples where we have multiple operations to do. So we might be dealing with multiplication, division, and the powers, maybe even some adding and subtracting. So let's start first with a. It asks us to simplify it and then also evaluate. So 2 different ways we could do this. One, we could remember what we just looked at in terms of the product of powers here. So that would be 2, and this would be 3 times 2 because we've taken this 2 and we've multiplied it by the 3, and we also want to multiply it by the 2 here. and that would be times 2, and then 1 times 2, which simplifies down to 2 to the power of 6 times 2 to the power of 2, which now we've got multiplication, 2 exponents, that's 2 to the power of 8, is equal to 256. An alternative way of doing this, so this is one method, or we could look at dealing with the brackets first. So our order of operation being brackets first, which means that in the brackets we have 2, and then the same base, we add the 3 plus 1. So remember, that's what we looked at when we were multiplying same bases with the exponents. That's still raised to the power of 2, which will be 2 to the power of 4, all raised to the power of 2, which is 2 to the power of 8. And like we saw before, 2 to the power of 8 is simply 256. Example B, again, we can do this in 2 different ways. So we could do it where we distribute the 2 to both the 4 and the 2, or we could do it with the method on the right, where we deal with what's in the brackets first and then to the exponents. I actually like to deal with what's in the brackets because that's what I remember in terms of order of operations. So if I deal with the brackets, it'll be 5 because that's my base. And then remember that with division, we subtract the exponents. So 4 minus 2 gives us 2, but that's all raised to the power of 2. So now we have 5, and the 2 is raised to the power of 2, so we go 2 times 2, which gives me 4. And if we take 5 to the power of 4, we get 625. Again, you could do it in the same way. We already distribute the 2 to the 4 here, so 8, and then the 2 to the 2 here, so 4, and that would be 8 minus 4, sorry, which still gives us the exponent of 4. The last 2 examples have addition and subtraction in them. We can't use these rules, the power rules, when we have addition or subtraction. We have to go back to the order of operations. We can simplify as much as possible using our exponent rules, and then we would do our addition. So in this question here, we have some stuff in brackets that are raised to power of 3 plus, so we can't do anything here, and then some more stuff in brackets raised to the power of 0. So we'll start with our first set of brackets, just reading left to right, and with those brackets, we have a division happening in them of same base of 2, so we just take our exponents and we subtract them because it's division. So that's 2 to the power of 1, and I'll write it there just so we remember. And then that's all raised to the power of 3. Now we're going to add, we haven't changed that at all, and our next one here, we're multiplying, so we go 7, same base, and since we're multiplying, we add our exponents, which is 7 to the power of 7, and that's all raised to the power of 0. Using our power rule, where we take the base as 2 and we multiply our exponents, 1 times 3 is 3, plus 7, and we multiply our exponents, 7 times 0 is 0, and so we can work through these since we're asked to evaluate. 2 to the power of 3 is 2 times 2, 4, times 2 is 8, plus anything to the power of 0 is simply 1, and so 8 plus 1 gives us 9. And that's a whole lot easier, I think, to deal with. We don't even have to use a calculator than dealing with 2 to the power of 3, dividing it by 2 to the power of 2, figuring out what those are, raising it all to the power of 3, and then over here where it's even worse, 7 to the power of 4 times 7 to the power of 3, those are really big numbers that we have to deal with. But if we just simplify it down, it actually ends up being 1, and we haven't had to use our calculators at all for that. The last question here looks confusing because we've got negative ones in here, but we can just work through it, remembering our different power rules. So reading left to right, we have a set of brackets here, and it's a negative 1, and then we've got 3 to the power of 4. So we've got negative 1 as our base, and then we multiply, because that's our power rule, 3 times 4, which is 12. And then we're going to subtract, and again, we've got some brackets here with the squared. So we've got our brackets, and we've got a negative 1 to the power of 4 divided by a negative 1 to the power of 3. Division of the same base means we can simply subtract, and so it's 4 minus 3. So we actually just are left with the negative 1, but we need to remember the 2, and so we put the 2 down there. Now we have a negative base, even exponent, so we know it's positive, and 1 to any exponent is simply 1, minus, again, a negative base raised to a positive exponent is simply going to be 1, and it'd be 1 squared, but we know that 1 to any exponent is simply 1. So it's actually 1 minus 1, which gives us 0. So this whole equation or expression simplifies down to 0. Now it's your turn to try some of the questions in the workbook.